Hi, welcome to Wednesday, September 9th, week 7. Today we move on with functions and we're looking at transformations. There are three types of transformations that we'll learn about. Translations, which are slides, okay? Reflections, which are flips, and you can flip right and left, and you can flip up and down. Okay, and then the last one are called dilations. That's where we're taking something and we're stretching it. We can stretch it horizontally or we can squeeze it horizontally. We can take something and stretch it vertically or squeeze it vertically. So let's get started. So today we're looking at translations. Okay, so translations are when we take a figure and we slide it. And there's four things that we're going to do to it, to a function. So if I had a generic function here, let's say just some function f of x. What we can do is we can take, remember, that symbol all by itself is the output. And then the x is the input. All right, now if we took a function and we added something to its output, what's that going to do to the graph? If we had a function and we subtracted something from the output, what would the effect of that be? Then the other thing that we're going to take a look at is, what if you do something to the input? So instead of adding something on the outside, we added something to the input, then plugged it into the function, and then the other option would be, what if you subtract something from the input? What is that going to do to the function? So it's important to realize when you're doing something to the input and when you're doing something to the output, because that's how you determine what's going to happen to the function. All right, so you can use either Desmos to do these, or you can use your graphing calculator. What I'm going to do is just use Desmos here, and it'll allow me to graph these functions really quick. All right, so I have the function f of x is equal to x squared. Okay, so our function right here is x squared. Okay, f of x is equal to x squared. All right, now what I'm going to do I got two graphs on here. One is a black one is a red. You can't see the difference because they're right on top of each other. Okay, what I'm going to do is I'm going to add something to the output of this graph. And what that means over here is, see where the variable k is? That is adding or subtracting something to the output. H is adding or subtracting something from the input. And right now I have H set on 0. So all I'm going to do is just move this k value. Okay. So, for example, if I took x squared plus 1, what would that do to the graph? Okay, so that's adding 1 to the output. So I'm just going to take k and slide it to 1. And you can see what it did. It moved the graph 1 slot up. If we look at the table, negative 2, 4 now became negative 2, 5. Negative 1, 1 became negative 1, 2. So what this did was it added 1 to each y-coordinate. So all this did, this just took the x-coordinates stayed the same, and the y-coordinates, we added 1. So every coordinate on this graph would be what they used to be, and then you would add 1 to the y-coordinate. So we can see that if I took k and I made it plus 2, That's taking every y coordinate and adding 2 to it. All right, and then conversely, if I took these coordinates, let me get my big head out of the way, and I subtracted 2, it's going to slide everything downward. Okay, but it doesn't, the x coordinates stay the same, it just affects the y coordinate, which makes sense because what we're doing is we're adding and subtracting from the output, and the output is the y coordinate. So that's the only thing that gets affected. So here are your overall results. Okay, the x's stay the same, and if we're adding 2, we're going to just add 2 to our y's. Here, subtract 2 from the y's. And the effect of doing that is it either is going to slide the graph up if you're adding, or it's going to slide the graph down if you're subtracting. And that's the simplest of the translations. That is, these are known as vertical translations. Okay, so down here, we're just showing what we did. Okay, this, remember, this is the f of x is the output. So we're subtracting from the output. It's going to translate the graph, whatever we're subtracting, downward. Okay, and then if we add to the output, then it's going to move it upwards. So remember, anytime you see f of x, just think that's the output. What would happen if you took the y coordinate and you added a number to it? It's going to move up. Now, the way that we describe these movements is we use vector notation. So a vector notation, actually in a vector, you use like these angled brackets, I should say. So sometimes you'll see the brackets that look like this, or other times it'll just be parentheses. All right, the top number in this vector, the series of 2 numbers, is your right and left number. And then your bottom number is your up and your down. Okay? So if I was moving something downward, my vector would be 0, and I'd have a minus k, meaning move down. If I was moving something upward, I'm not moving it right and left, this is 0. If I wanted to move it up, I would have positive k. So if I describe this transformation with a vector, it would be the vector 0, 1. That's what we did to that graph. We didn't slide it right and left, we just slid it up 1. This we would describe with the vector 0, 2, because it went 2 up. And this one would be described using 0, negative 2. Okay? So that's what we're talking about here. Okay? We took the output and we added a number to it. Whatever that number was, it slid the graph upwards if this number's positive. Okay, and the translation vector would be this. Remember, this is right and left. And since that's positive, you're going to move it k spaces up, or k units up. Okay, so we're adding to the output. And then if that k was a minus, okay, now we're subtracting 1 from the output. And that's going to take this blue graph is everything on this orange graph with the y, with 1 taken away from the y coordinate. Okay, so this represents k spaces or units down. And this would be 0 units right and left. So that's our simplest of the translations. That's a vertical translation. And it only affects the y coordinates. Okay? When we do a vertical translation, it's only going to change the y coordinates. All right, so if I was looking at this, this is the output. Okay, so this is an example of the output take away 3. So that's really the same as taking each y coordinate and subtracting 3. So if I was going to graph this, I would just pick some points and take each one of those points and drop them down 3 places. And then connect my dots. Okay, and then that's the graph f of x minus 3. The graph shifted 3 down. Okay, now if you look at the next set of examples here, what we're doing is, instead of adding and subtracting to the output, we're adding and subtracting from the input. And what that does is it slides the graph right and left. So we're taking the input, which is x, and then we're either adding a number like 2 or subtracting a number like 2. Now, what happens here, I often call bizarro world. Because you'd think, well, if I'm adding 2, why doesn't it slide to the right? Well, it actually slides to the left. Okay, so here are my 2 graphs again, just the parabola x squared. And now what I'm going to do is I'm going to, all right, I want to create the equation that looks like x plus 2. So in order to do that, if you look at the form of this equation, it is x minus h. So in order to make that look like a plus 2, I actually have to make h negative. All right, so when I go over here and I move this negative 2, 1, 2, whoops, right there, there we go. So I moved it, h is negative 2, but when you put it into this equation up here, it becomes f of x, the input minus, but h was negative 2. And when you have 2 negatives, then you get a positive. So even though this says plus 2, it's really negative 2. Or 2 left. And that's why I call it bizarro world, is because when I see a plus 2, it's really a -2 when I'm dealing with the input. Because your common sense would say, wait a minute, shouldn't that go to the right? Well, no, because of the way these equations are written, it's actually the reverse when you're working on the input. So if I wanted that equation to look like h minus 2, then I'm going to make h positive. So as I move this to +2, and I write it in, I copy this formula right here for g of x. When I copy that, if h is 2, I just put a 2 in for h, okay, and now those are the same, but what it did is it actually moved it to the right, okay, so that's why I refer to this as bizarro world, okay. You're going to take the x coordinates and you're going to add 2 to all of them. Okay, on this other one, you're going to take the x coordinates and you're going to subtract 2 from all of them. Okay, and the y coordinates now stay the same. Okay. So when you're working on the input, think bizarro world. So when I see this, -4, my intuition says, well, that's really 4 left. No, we're in bizarro world. This would be, take the x coordinates and add 4. So this is going to slide it 4 units to the right. If I wrote that as a vector, it would be 4, 0. The 4 means 4 right, and the 0 means you're not going up or down at all. If I was writing the vector for this one, my vector would be 2 left, 0 up or down. Which slides the graph to the left. Okay, so that's why I talked about input and output. This is working on the input. So you either add or subtract from the input, then you plug that number into the function. Whereas before, you plugged in the input, and at the end, you added or subtracted. All right? And then when you're doing it, just always remember, this is bizarro world. When I see plus a number, I'm really moving left. When I see minus a number, I'm really moving to the right. So when you hear me say bizarro world, that's what I'm talking about. Okay. All right. So here's a summary of what we just came up with. I'm adding 2 to the input, which is really sliding it to left. Add 2 to the input, is the same as sliding to left. And that's how I represent it using a vector. So when we add a value to the input, okay, it's actually, when it looks like we're adding to the input, we're really not. Okay, you're really moving, the graph is really moving to in the opposite direction that you would assume that it is. That's what we mean by bizarro world. Okay? So when you see that vector, the way you'd express that, that would look like this: x plus some number k. Okay? We're adding to the input, which is really sliding left. When I see this, this means slide left. And then the reverse of that would be, now I'm subtracting from the input, and that's actually taking the graph and sliding it right. So when I add to the input, this is actually adding to the input. It's going to move the graph to the right, even though it says -1. You're actually adding 1 to every x-coordinate. If I saw this, what I would do is take every x-coordinate and add 1. When I see this, now what I'm going to do is I'm going to take every x-coordinate and subtract 2. And the y-coordinates stay the same. So bizarro world also a lot of times confuses folks a little bit. Alright, so when I look at this, okay, I see +2, but it's happening to the input. So I automatically go to the upside down world, bizarro world. Okay, so this really means every x-coordinate subtract 2 from it. So that's going to take every x-coordinate and slide it 2 places to the right. And then connect your dots. And there is f of x plus 2. Everything moved 2 to the left. Okay, as a vector, to left is written like that. So what I put on here, guys, is a summary of what we just did and what it does to the original coordinates. All right, so when you have these two here, you're adding or subtracting to the output. And then these two, you're adding and subtracting from the input. So when you're dealing with doing something to the output, it's going to move it up or down. And the only thing it changes is the y-coordinate. Okay, the x-coordinates are the same. and I'm going to add, in this case, 2 to the y coordinates. Here, the x's stayed the same, but I subtracted 2 from the y coordinates. Okay, now, the way that we would write this as a vector, this as a vector would be 0, 2, and this as a vector would be 0, negative 2. All right, now when we're dealing with doing something to the input, that's when you're thinking bizarro world. So this is really subtracting 2 from the x coordinates. So I'd write negative 2. And if you look at this, I took 6 and I subtracted 2 to get 4, and the y coordinates stayed the same. So this is going to slide it left. That's what a left slide looks like. And now if I'm subtracting 2, it's going to slide it to the right. And as a vector, that would be positive 2, 0. And you can see I'm taking the x coordinate and I'm adding 2. Y coordinates are unchanged. So these two examples only affect the x's. And I don't know if it's affect or effect. So I think it's the A. Okay, and these two only affect the y coordinates. Alrighty. Okay, that's not part of what we're doing today. So here's another summary. Okay, so let's just cross this out. We're doing this is reflections. We're doing this later. Okay. So if you looked at, this is a summary of what we did. This is 2 up. So the y coordinates got increased by 2. This is 2 down, so the y coordinates got decreased by 2. That's how you would write those movements using a vector notation. Okay, over here, minus 2 is really 2 to the left. Okay, so I subtract 2 from the x's. This is what 2 to the left looks like. This is minus 2 to the input. That actually takes the x coordinates and adds 2. And that would be represented with the vector 2, 0. All right. So when we look at this, this one says take this graph and create this translation, 2, 0. All right, so the 2 tells us that we're going to take each y coordinate and add 2 to it. Okay, so let's see here. The y coordinates plus 2 and the x coordinates minus 3. So everything's basically going 2 up and 3 left. So this point would go 2 up, 1, 2, 3 left. Okay, 2 up, 1, 2, 3 left. Okay, this point, 2 up, 3 left. And then this point, 2 up, 3 left. And there's my graph. Now the way I would write that, the notation for that, this would be, it went 2 up, so that's positive 2. Now remember, it went to the left 3. So I got to write that in Bizarro world. That would be plus 3. Three left is written as x plus 3. All right. Suppose you have the function f of x equals x squared, and it's transformed by this equation. All right, so let's, over here, I know that that 2 right there, I'm going to take the y coordinates, and I'm going to add 2. All right, then when I look inside here, I got to think Bizarro world. And what I'm going to do is take the x coordinates and add 3. So what this movement is, this as a vector would be 3, 2. 3 right, okay, 2 up. All right, so if I had the point -3, 9, what would the point be on, what would the image of that be on G? Well, I'm going to take my x coordinates and add 3. So that's going to be 0. I'm going to take my y coordinate and I'm going to add 2, and that would be 11. So this was -3 plus 3, and that was 9 plus 2. Now part B is asking for the reverse. If you knew, if you had -2, 27 on the second graph, g of x, well, what was it originally? Well, if we wanted to go backwards now, well, we added 3 to get the new x coordinate. Now you're going to subtract 3. And this would be -5. If I added 3, I'd be at -2. Okay? The reverse of adding 2 to get the y coordinate. Okay, I added 2, so now I'm going to subtract 2. And that would be 25. Okay, the last section here is, how could you rewrite this equation if you wanted to translate it 4 down? All right, so 4 down means take the output and add 4. So that's simply going to be 2x plus 3 plus 4. So that would be 2x plus 7. Okay, if I wanted to, I'll skip to C here because it's an up and down. So now I'm going to take f of x and I'm going to add 3. So I'm going to take this equation and I'm going to add 3. And that's my new equation. We'll call it g of x. This one was 2x plus 7. All right, last two. If I want to go 2 left, then I got to think bizarro world. Okay, so 2 left is take the input and add 2 to it. Okay, so this would become 3 times x plus 2 minus 4. And you could leave it like that, or you could simplify it. 3x plus 6 minus 4, which is 3x plus 2. Any one of these is okay. This is all right. Says that. All right, 5 right. Okay, so 5 right means I gotta be thinking bizarro world. Okay, so 5 right means I'm going to take x and I'm going to subtract 5. That means 5 right. So wherever I see an x, I'm going to put in x minus 5. And when you're doing this on Math Excel, you don't have to simplify it. You can just leave it like that. Okay? Or if I wanted to, I could simplify that whole thing. I'll do it here. And there it is written out if you had to go further. I just simplified everything. 5 right is really written as x minus 5. So I substituted that in for every instance of x. All right, folks. So for this is going to be due on Thursday night. And our last assignment will be given on Friday, and then next week is a makeup work week. So the teachers will be back at school. We got to learn all the new processes. So if you're all caught up, you won't have any new material next week. All you have to do is do the quick assignment check. All right, take care, and I will see you next time.